to use the Gauss's divergence theorem to evaluate the surface integral where f vector is given to us and S is the surface of the sphere x square plus y square plus z square equal to a square, where a is the radius of the sphere, right? Okay. So f vector is given to us and also the surface S is given to us. So we need to apply the Gauss's divergence theorem to evaluate the surface integral of dot product of f vector with ds vector. Now what is ds vector? It is the vector area of the surface. If I multiply the n vector with ds, ds is the magnitude of the area of the surface. So if I multiply this ds with n vector, what is n vector? It is the outward unit vector normal to the surface. Then this product is equal to ds vector, that is the vector area of the surface, right? So ds vector is equal to n vector multiplied with ds. So we write this surface integral to be equal to the surface integral of dot product with f vector with n vector ds, right? Okay. What is the Gauss's divergence theorem? It is the surface integral of dot product of f vector with n vector ds is equal to the volume integral of divergence of f vector dv, right? So we need to evaluate this surface integral, right? That is dot product of f vector with ds vector. So this is equal to the surface integral of f vector dot product with, for ds vector I am writing n vector multiplied with ds. And now applying this Gauss's divergence theorem, so this is equal to the volume integral of divergence of f vector using Gauss's divergence theorem, right? Okay. So this is equal to the volume integral, okay, writing the divergence of f vector, that is del dot f vector dv. So this is volume integral of curly by curly x I vector plus curly by curly y j vector plus curly by curly z k vector and its dot product with f vector, where f vector given to us is x cube I vector plus y cube j vector plus z cube k vector dv. So taking the dot product, we get curly by curly x of x cube plus curly by curly y of y cube plus curly by curly z of z cube dv. So this is equal to the volume integral of curly by curly x of x cube is derivating x cube with respect to x, that is 3x square plus curly by curly y of y cube is 3y square and curly by curly z of z cube is 3z square. Taking this 3 outside, we get 3 times the volume integral of x square plus y square plus z square dv. And because the surface given to us is x square plus y square plus z square equal to a square, so I am writing a square for this. So this is further equal to 3 times the volume integral of a square dv. Taking this a square outside, we get 3a square the volume integral dv. Now evaluating this volume integral, we write 3a square the triple integral of 1, and for dv I am writing dx dy dz, right? Putting the limits of x for the inner integral, we are having the surface given to us as x square plus y square plus z square is equal to a square, right? So limits of x becomes plus minus a square minus y square minus z square under the root, right? So writing here the limits for x, that is square root of a square minus y square minus z square with negative sign, and square root of a square minus y square minus z square with positive sign. And now putting the limits of y, and now putting the limits for yz plane, x is 0, right? So from the surface S, we are having the limits of y to be now equal to plus minus square root of a square minus z square. X is 0 for yz plane, right? So the limits of y becomes negative of square root of a square minus z square and positive square root of a square minus z square. And then the limits for z, so where x and y both are 0 for the z-axis. So from this surface, we are getting the limits of z as plus minus a. So this is minus a and this is positive a. So first we are going to evaluate this innermost integral, that is having the limits of x. So this is equal to 3a squared, and the integral of 1 is x with limits minus square root of a square minus y square minus z square and plus square root of a square minus y square minus z square. So this is equal to 3a square square root of a square minus y square minus z square minus, putting the lower limit, this is minus of square root of a square minus y square minus z square dy dz. So this becomes positive and we get twice of the square root. And now I am taking this 2 outside and multiplying with this 3. So we get 6a square, right? And now evaluating this second integral, that is integration of this with respect to y. So for y, a and z are constant, right? So let me write the constant terms together, that is a square minus z square, and then writing minus of y square. Okay. Now as this is your even function, what is even function? If f of negative x is equal to f of x, then the function is even function, right? And if f of negative x is equal to negative of f of x, then this becomes your odd function, right? So for even function, if I integrate f of x with the same limits but with opposite sign, then I get this integral to be as, for even function, it is twice the integral of f of x where limits will become from 0 to 2. It is equal to twice the integral of f of x with limits from 0 to a. So applying this result over here, as this is your even function, so the limits become twice the integral with limits from 0 to square root of a square minus z square, as this is the even function, right? Okay. Multiplying this 2 with 6, I get 12a square. Fine. Alright. Let's evaluate this integral now. A square minus z square is constant because this is the integration with respect to y. And we are having the formula for this, that is integration of square root of a square minus t square dt is equal to t divided by 2 square root of a square minus t square plus a square by 2 sine inverse t divided by a plus constant, where this a is the constant and the integration is with respect to t. Here a square minus z square is constant and the integration is with respect to y. So matching the result, so replacing this a with a square minus z square under the root and replacing this t with y. So applying the formula here, t divided by 2, that is y divided by 2 square root of a square minus t square, that is square root of a square minus z square minus y square plus a square by 2. A is square root of a square minus z square, right? So if I take the square of this, I get a square minus z square divided by 2. Then is sine inverse t by a, that is y divided by square root of a square minus z square, right? And because we are having the limits, so writing here from 0 to square root of a square minus z square dz, right? On putting the upper limit, we get this term to be 0, and the second term becomes sine inverse square root of a square minus z square divided by square root of a square minus z square. That is, this becomes sine inverse 1, and sine inverse 1 is pi by 2, right? So let's put the upper limit. So this is equal to 12a square integral from minus a to a. On putting the upper limit, we are getting this first term to be 0, and the second term becomes a square minus z square divided by 2 sine inverse 1. And for sine inverse 1, I am writing here pi by 2. Is it okay? Alright. Minus, when we put the lower limit, that is 0, for y, the first term becomes 0, and the second term sine inverse 0 is 0. So it is minus 0 dz. So this is equal to, the denominator becomes 4, and I am taking this 4 outside. So I get 12 divided by 4a square integral minus a to a square minus z square into pi dz. So this cancelled out and we get 3a square. Let me also take this pi outside. So this is 3 pi a square, right? Okay. Again, I'm having this to be as the even function, and the limits are same with opposite sign. So this integral becomes twice of a square minus z square dz, but the limits will now become from 0 to a. Multiplying 2 with 3, I get 6 pi a square, and integration for a square is a square z. Integration for z square is z cubed by 3. So this is minus z cubed by 3, and the limits from 0 to a. So this is 6 pi a square. Putting the upper limit, we get a cubed minus a cubed divided by 3, minus, putting the lower limit, we get this to be as 0 completely. So this is 6 pi a square, and this is 3a cubed minus a cubed, that is 2a cubed by 3. So this cancelled out, and multiplying this 2 with this 2, we get 4 pi a the power 5. That is your required answer. Alright, thank you. Stay blessed.